Hello everyone. I appreciate so much for you taking time listen to this presentation. In this presentation I will talk about the new techniques I proposed. The name of the project is called Grief Free. Grief Free is a project that I want to use it to support any distributed system programming over the internet. I think distributed system development is very difficult, and most developers do not want to use some traditional programming language to programming distributed system. For example, here I list some examples. The first one is C, C++, Java, or Python. All the programming language I call classic one or mainstream programming language, or sometimes compared in terms of distributed system programming. These languages can be regarded as low-level ones. So that means developers cannot use them to implement distributed system directly, because a lot of issues should be considered. For example, concurrency, right? And distributed architecture. A lot of issues need to be taken care. Before the system is set up, concurrency and distributed modeling, architecture, and maybe networking, synchronous management, and multicasting, and clustering, caching. A lot of details need to be cared to establish distributed system. So if we need to create a distributed system with a mainstream programming language, so almost nobody do that at this time. Only some highly proficient programmers can do that. So at this time, only distributed frameworks, usually distributed frameworks are employed to construct distributed system. However, distributed frameworks is a domain-specific one, rather than not generic, right? That means they're just focused on one particular environment for one specific cases. Here I list some example or some major category. You can see distributed enterprise objects environment. In such a category, one is important example is Java Enterprise Edition, right? In here, all the computing resources and the business logic are described in entity, just similar to object, right? It's a entity, just like objects. So all the enterprise entity being something like this, right? So all the computing resources are described in objects, so can be virtualized to objects. But maybe for some specific design of small scale, for some small scale system, is fine. But for the completely distributed computing environment, it's impossible. RMI or RPC, enterprise RPC, yeah, remote procedure call is also one type of distributed framework, right? Some for RMI is supported by Java, and so developers can use a remote procedure call to access remote computing resources, remote algorithm, remote data. However, because RMI expect to provide developers with computing programming environment. In such environment, developers do not need to care about the details, whether the resources, where the distance, the location of the resources are transparent or invisible to developers. However, when the scale of the system is large, when the system the computing environment become complicated, developers should care about the locations, to care about the distributed architectures, to care about the data transmission, to design a high performance system. So RMI here, and I think is just for small scale system, and the computing environment is stable, homogeneous, and for such a system, simple system is fine. But for complex system, we cannot guarantee the quality of system, right? Concurrency is there are a lot of different concurrency system, right? So concurrency is most difficult to be programmed, and because there are a lot of types, there are a lot of forms, there are various different scenarios to for concurrency. So for different distributed system must have different relevant forms of concurrency. So distributed framework cannot cover all of them. It just so most of them focus on one case, MapReduce. For example, Hadoop, right? Hadoop can solve this problem. So can provide developer with environment to program the MapReduce like concurrency, but there are still some other ones. So if so, I think Hadoop just solve one particular case. Because it's very difficult to design a framework or a software system that can cover all the forms, all the varieties of concurrency. Clustering is also abstract term, too abstract. Because when we mention cluster, we just need to know the architecture, how many computers, computer devices participate in such cluster. How many? What about the topology? What about the architecture? What about the transmission protocol? How to scaling? What about what is a scaling out strategy, right? So for different cases, there are different cluster. Even for enterprise, we still need to answer those questions. So clustering is difficult to it's impossible for us to give one solution for all the cases. However, usually we have to construct cluster. Usually we can use for the Spark. We can use Spark to design a cluster. But this cluster is from my point of view is just one case, not for not generic. Infrastructure, OpenStack is one case for infrastructure enterprise environment. So the hardware, the network, the computer devices are abstract as one particular APIs or software interfaces. So developers can use those computer devices conveniently. So OpenStack just like this, yeah. But it's impossible for similar to other distributed frameworks. OpenStack is cannot be generic, yeah, because it's too heavy, right? It's in some cases, or especially in the internet, all the computers may work together. It's impossible for us to install OpenStack to all the computer devices, right? So all the frameworks, including OpenStack, is not easy to be changed. We have to just do some configuration. What developer can do is just the configuration, right? Configuration is not programming, right? Or scripting. Just describe their requirements. We cannot use such language to design any distributed system which is not predefined. So OpenStack is also not a generic. It's just a framework. It's a semi-constructed environment, right? Data management. I give you example HBase, right? HBase is established based on the Hadoop, so developer can use HBase to manage large, high volume data. But it's also just one case, yeah, just for enterprise environment. For general purpose one, we have data is very difficult. There are different approaches to manage data. So Hadoop, it just can only manage the data of the based on Hadoop. So, but Hadoop is a large is a distributed file system, and such a distributed file system is also domain specific for enterprise environment. For the for example, the search engine, the all of the data is huge, but the data can usually write once, read many, right? Just like this kind of data, and we cannot use it in some other environment. For example, I gave you a extremely case, BitTorrent. I also implemented a new system called New World Wide Web. All the data is dynamic. All the data has no any the structure is different, and it updates all the time, and all the data is organized together. We cannot predefine the structure. We cannot give a form or any other predefined structure to describe approach to describe all the data. We have used some very specific way to describe the data. For example, the complex network or social network. This is what I done in my another project I call New World Wide Web. It's another project I'm still working on. Another project I'm working on. It's huge, right? In New World Web like system, data should be organized in a social network, in the way of social networks. So it's very difficult to be managed, right? So Hadoop cannot be used in this way. Streaming, Kafka. Kafka is for streaming, but it's also used for enterprise environment only. Yeah. High level scripting language. I can mention JEE or Spring again. JEE when we use JEE, we can use Java directly, but Java just focus on object-oriented program modeling. Object-oriented modeling. We do not care about a lot of the details. The system is J2E provide developers with a virtualized computing environment. In such an environment, developers do not need to care about any. This environment runs in similar to a single thread and no networking. Just for describe the business logic using object-oriented modeling approach. We just describe the business logic with object-oriented modeling approaches. So in such a system, I call it virtualized. Although it's a distributed system, but JEE virtualize it as a standalone and synchronous environment. So it's easy for developers to implement enterprise system. Although enterprise system is distributed for sure, but J2E virtualize it to be a standalone and synchronized one. So we just in such a way, although Java still used, but such a Java, the JEE become a script. That's what I define script, just like scripting. A lot of Java features do not need to be used, so it's easy for developer to implement distributed system. Yeah, but although the distributed system is simple, yeah, this is what high-level scripting mean. Sprint is similar. Customer application. Solar is one example. Solar is just used for search engine. Search engine is just one specific application, right? This is the application. So such a framework, Solar, is a application specific framework or technique. It's impossible to be generic. It's not generic. So in summary, all the distributed frameworks we use at present are generic. Not generic, domain specific. So what I want to do is to design a generic and self-contained distributed programming paradigm, such that developer can use such a programming language to implement any distributed system conveniently. Or that's my goal. Yeah, this is my goal. Motivation. Another motivation is that there's still some this I just mentioned the motivation. I can repeat explain these slides here. All the distributed framework techniques are, as I said, not generic. I have just mentioned. For some complicates, there are no corresponding frameworks. For example, BitTorrent, for instance, BitTorrent is a system. When we design such a system, we have to use traditional programming language. For example, BitTorrent is a program with Python. Another example is the new World Wide Web. It's also, I just mentioned this project I'm still working on. This system is called large scale. It's actually a large scale heterogeneous socialized distributed system. Large scale. Sometimes, so this is what I define new new World Wide Web. That system is a large scale heterogeneous socialized distributed. This system, we no any distributed frameworks can support us to design such a system. The scale is large. Sometimes maybe the scale is a global scale, right? And heterogeneous means the data is different. Yeah, the data have different structure. We cannot predefine the structure, and the scale is large. And the human, the computing resources are distributed in different ways, and there are the behaviors of human being also influence such a system, and so some computing system is and all the human beings have have their own computer devices. Some computer devices is powerful. Some computer devices is weak, but they are organized together, and all the computing devices are organized in based on their willingness rather than based on their based on predefined machine algorithm. Usually, and all the distributed frameworks focus on in contrast. Distributed frameworks just focus on compared with that, it's a small scale, homogeneous, and machined distributed system. They're quite different, right? Most of all the distributed frameworks focus on the later one. Yeah, such a computing environment. The computer environment is easy. Yeah, much easy, and there are different natures. So we can only use at this time distributed frameworks can only at most can only support developers program the small scale homogeneous machine distributed system. And so you can see here it's tough to make any changes to existing frameworks to adapt to specific environments, because all the distributed frameworks is I call it semi-constructed ones. not not programming language. We just do some configuration, right? We cannot use them to program. They are not flexible enough, not flexible for us to adapt to adapt to new environment, new requirements, right? Sometimes because when we use some frameworks, I'm not sure why because it's not easy for us to manage them, to make changes to them, so we have to use them. Maybe sometimes it's a waste of resource, but we have any other solution. If we have programming language, we can design this system from scratch. So we can use the programming language to solve the one particular problem. We do not use the frameworks to install them on my computer, but a lot of functionalities are not used. It's not good, right? So that's why I say that it's a waste of resources. Limited coverage means for example, in my system, I also have ever used some in my system here. This is the one I just new World Wide Web. In such a system, I have to use Hadoop, Solr, and although I use a lot of underlying techniques, I still use some existing frameworks for Solr, Tomcat, and sometimes I use HBase, caching. Yeah, I use some existing frameworks, but you can see in one system I have to use a lot of and even DB, right? A lot of underlying other many third party frameworks to support one system development. It's not easy for us. Not easy for us to management, right? So I think we have to use a lot of distributed frameworks together to design a system. So that means one the coverage of one distributed frameworks is limited. So my goal is I hope I can design a new distributed new programming technology. It's a flexible techniques, and we can use these programming techniques to design various distributed systems to adapt to various distributed computing environments. I think this is my goal, right? I think here some other developers and researchers have already proposed some new programming paradigms. They have similar goal to me. They also call their solution is a general purpose solution. For example, Erlang here. Erlang was proposed in 1986. It's very early. Akka is another is a new techniques proposed in 2009. And Go. This is this Go is proposed by Google. These three languages is not cover all the competitors, but they are typical ones. So I just try to compare with them so you can know what I have done in my system. All of them here, I think Go, Erlang, and Ika, they have this very they use the same technique. They use the same thing to describe, to support their software development. They have a model. It's called the actor model. Actor model is a synchronous messaging programming component. So different from traditional programming language, Go, Akka, and Erlang, I call them is a synchronous and distributed paradigm. Traditional programming language such as C, C++, Java is a synchronous and standard learn paradigm. That's quite different, right? So there are because we need to programming. We need to implement new distributed system. So because there are we using traditional programming language are very difficult, so we have to change the methodology, the primary methodology. So those new programming techniques is called asynchronous. That means when by default such software designed with those techniques is runs in is a concurrent system, and by default such a software system or such programs is a distributed system. This is by default. We don't need to make specific we do need to do something that to transformation to we do not need to use some difficult programming techniques to do such transformation. For example, if we use C or Java programming language without any explicit declaration, such programming languages can only design synchronous standard learn paradigm. If we want this system can run in a distributed environment concurrently, we have used some special techniques. For example, we need to use threading. We also need to use networking. These are two fundamental techniques. We have to use such two techniques to convert or to transform synchronous and the standard learn system to a synchronous distributed paradigm. But this transformation is very difficult. It's hard. Very difficult, right? So nobody wants to do that. So such programming paradigm should be the future of programming, right? So I want to my system also grid-free. Grid-free is also asynchronous and distributed paradigm, but I want to make comparison between my grid-free with Go, Erlang, and Akka. The actor model. Actor model is actually is a concurrency model using message passing. Right? This is the actor model is just like this. So the Go, Erlang, Akka use such a programming model. I also use asynchronous message passing concurrency model, but I make a lot of make some important updates to such a model. I will explain that detail later. This is my programming paradigm, right? My programming paradigm is also called asynchronous and distributed paradigm, but there are a lot of difference. Here, there's three major difference here, at least here. The first one is the distributed primitives. All the existing programming techniques do not talk about this issue, distributed primitives. That means if we want to design and provide developers with a high efficient programming environment, we need to provide them with some fundamental APIs or techniques. Using those techniques, developers can implement some more complete APIs or other distributed techniques to support their future potential very complete distributed system. Because that means although it's impossible for us to provide all the APIs, all the techniques to design distributed system. It doesn't matter because we have some fundamental elements. We can use these elements to design, to help developers to come up with new APIs or new programming components to develop a complete distributed system. So for each system, for each programming paradigm, it wants to be generic and it's very self-contained, right? Self-contained is also important issue. That means we do not need to use any other third-party programming paradigm to support our system. We just use only one technique to do anything, right? That means self-contained. Akka, Go, and Erlang do not talk about this concept, distributed primitives. That means if no one particular API or techniques is not available, we cannot program with Akka and Go and Erlang to design such programming model. For example, peer may be simple, right? Cluster, multicasting, clustering, right? There's some in my system way. I have created root, cluster root, cluster child. For multicasting, I create root client, root child. This I call this API is advanced API. All the advanced API is created by distributed primitives. I proposed. All the APIs here, I call it the advanced API, but all the advanced API are created by the distributed primitives. To be a new programming languages, new programming paradigm, distributed primitive is very important. It's a fundamental techniques, but Go, Erlang, and Akka do not talk about this issue. Asynchronous messaging on the thread level is another important technique in my center. I just mentioned actor model is a asynchronous messaging concurrency model. However, ACTIV model, when we use ACTIV model programming distributed system, thread is not visible. Thread is not visible. Threads are not visible. A common sense is that everybody know that for different computing environment, there are different concurrency model. So we have to use different different approaches to manage the threads, the thread pool. Thread pool is should be designed case by case, right? Should be designed case by case. That means that there are no omnipotent thread pool. No such thread pool, right? No such thread pool that can do anything. It's impossible. We cannot use any thread pool, one thread pool to process any concurrency model. If so, thread should be visible. If thread is not visible, how we can provide developers with techniques that they can design their own thread pool? Yeah, that's an important issue, right? So that means if thread is not visible, the computing environment is not generic. This is still domain-specific one. They still focus on usually in enterprise computing environment, they still focus on this environment, right? They cannot take care about this system. So if thread is not visible, such a system is not generic. Standard state patterns with rich APIs. This is that important techniques in my system. Rich API means that because the system is difficult, a distributed system is difficult to complete. Though we have to design various APIs to establish such a system. However, in my mind, after I program a lot of code, I noticed that homogeneous distributed system, although system, there are a lot of different types of distributed system. So distributed system usually is the nature of distributed system is heterogeneous, right? However, heterogeneous system it's a heterogeneous system. How heterogeneous? Distributed system, the nature of distributed system is heterogeneous, right? I'm sorry for that, for the mistake. Distributed system is heterogeneous. This is his nature. However, such a system have a homogeneous code structure. This is the important discovery. If so, that means we can, because different, if this this idea is this discovery is correct, that means we can encapsulate all the different various or heterogeneous system with compatible syntax and semantics. Then, if so, it's possible for us to propose. Then the language, the new language, the new distributed programming language becomes simple, right? Because various distributed systems have a heterogeneous system have a compatible interface. So we can encapsulate the distributed system with compatible or similar syntax or semantics. Then the programming language, then distributed system can be programmed, can be designed with simple approaches, simple or consistent description. You can use some consistent description for various distributed system, right? So that why those three important techniques are so important, right? These three techniques are quite crucial for a new programming language, new generic and self-contained languages, programming paradigm. That's very important. They're the foundation. They are foundation techniques, fundamental techniques for the new techniques I want to propose. So I maybe I will explain that later in next class. So this is just a brief introduction. So if you have any questions, you can email me, and my email address is you can see here, right? I have some connection here. You can connect, discuss with me through this. This email address, and I have also a group to talk about that, and this project is published open source here, so we can interact with each other. In next class, I will explain those techniques maybe in detail. So if you have any questions, we can exchange ideas. And I'm still working on these projects, and I think this project is promising, and in the near future, I think I hope this can be turned out to be a new programming language so that can help developers implement a complete distributed system. Okay. That's all for today. Next class, we'll continue to talk about this. I will give you some code. I will program some simple system because we have limited time. So we just create some simple system. You can follow what I have done to understand my technique better. Okay. Thank you so much.